Okay, as promised, I'm back with part 3. Now we're going to find out how we find use cross products to find the equation of a plane. Now to do this, before we do this, we're going to take a look at how this works. Imagine we have two vectors intersecting. And we'll call this vector V and this vector W. Earlier in the first part, we talked about if you have two vectors intersecting, that they form a plane. So V and W form a plane. We also know from earlier from the cross product, if I cross V and W, we know that this cross product will be perpendicular to both vector V and W as well, and therefore perpendicular to the plane itself. And we know that from earlier, like from our right-hand rule. If I take V, cross it with W, we're going to be perpendicular. Now in this case I'm going down, but and even if we do the opposite, W cross V, we're still going to be perpendicular to this plane, to this piece of paper. For example, this pen can represent that vector. Understanding this along with the dot product, can help us write the equation of this plane or this piece of paper. For example, V and W line this paper, so we can imagine this piece of paper being that plane. If we were to take V cross W, and if we were to dot it with any vector on this plane, well, we already know it's perpendicular to V and W, so let's say we cross it with vector V. It wouldn't matter if we take V cross W and cross it with W as well. Both of them would be the same. They would be 0, because we know that if two vectors are perpendicular, their dot product has to be 0, and that's what we have here. Because V cross W is perpendicular, that our cross product is perpendicular. Now, for simplicity, because it's the same answer, we're not going to worry about this W. We're just going to solve it for using V. You can use either of the vectors. To do this, the first thing we have to do is write out vector V. Well, vector V, if I call this X naught, Y naught, Z naught, remember we are in 3 dimensions, so we have to have 3 space. And up here at the point where it ends, X, Y, Z. Well, vector V could be written as X minus X naught, comma, Y minus Y naught, Z minus Z naught. Now, VW is also a vector. We talked about that before. When we did the cross product, we get a vector. It also has components. We're just going to name them A, B, C. Look at the example above, and you can kind of see that these are vectors. I think it was negative. It would have been negative 10, negative 5, and 5. Well, V in component form is right here. X minus X naught, Y minus Y naught, Z minus Z naught. And if we do the dot product, well, we know that this should be equal to 0 because that's our rule, because it's perpendicular. So we get A multiplied by X minus Y, X minus X naught, plus B, Y minus Y naught, plus C, Z minus Z naught, and that will equal 0 for us. And this is the equation of our plane. These points lie on this plane. This would be the equation of our plane. So let's take a look at an example. We want to find the equation of the plane that contains the following points, P, Q, and R. Well, the first thing we have to do is we have to find two vectors in the plane. Any two will work. So I'm going to list it out, P, Q, and R. The first vector I'm going to find is PQ. It doesn't matter any vector. There's 6 vectors here. PQ, QR, PR, RP, RQ, QR. I'm just going to find the vector PR. Now I'm going to call that vector V. So vector V will be PQ, And to find PQ, remember we're going to take the point Q minus R. Minus P, not R, minus P. Remember, terminal point minus initial point. Terminal point minus your initial point. And if I do that, that's pretty easy to get. Let's see here. Negative 1 minus 1, negative 2, 1 minus 0, 1, 2 minus 2 is 0. Order is important. Remember, direction matters. So we're going to be really careful. Okay, so next vector I'm going to find, starting at P, go to R. I want them to intersect, but I'm also always careful about the direction. It may not matter here, but sometimes they may want to say, hey, look, find the angle. You might as well have the vectors already ready for that. And we'll call this vector W. Vector W is PR. To get that one, we're going to take R minus P. So it'll be 5 minus 1, which is 4, 0 minus 0, which is 0, 3 minus 2, which is 1. Now the next thing we want, so after you get your two vectors, remember this forms our plane, this is our plane, right? Next thing we have to do is use cross products to find the vector orthogonal. Well, if we take V cross W, I would go I, J, K, negative 2, 1, 0, 4, 0, 1. And I'm going to use the expansion by minus, cover the i's. I can't see, right? That would give us I, 1 minus 0, minus, don't forget, we're going to do minus here, do the j's, negative 2 minus 1, so it'll be minus 2, negative 2, minus 0 becomes a negative 2j, doing the k, plus, don't forget k, we do plus, this becomes 0 minus 4, so negative 4k. So we would have I plus 2j minus 4k. And that would be the equation of our, that would be our vector. Now remember, we're now going to write the equation of a line. Oh, whoa, somebody might have asked, what if we did W cross V? Well, remember, the equation says it's equal to 0. I can always, remember, if I change the order, all my signs will be opposite. Since it's equal to 0, we can just factor out that negative, and that'll be okay. So to write the equation of our plane, we're just going to plug this in. We plug this in. This is from our dot product. We're going to apply that dot product that we talked about earlier. So we're going to take a look at that if you need to. Here's our equation of our plane. A, B, and C come from the orthogonal vector, so A, B, C will correlate to 1, 2, negative 4. X naught, Y naught, Z naught correlate to any of the points. Any three of these points. Doesn't matter which one you pick. I'll pick the first one. 1, 0, 2. Alright, my equation, it says take A, 1, X minus 1, X naught, plus B, which is 2, Y minus Y naught, which is 0, minus 4, because C is negative, minus 2 equals 0. And there's our equation. You can leave it like this if you want to, that's fine, or you can simplify it, X minus 1 plus 2Y minus 4Z plus 8 equals 0. And that would give us X plus 2Y minus 4Z equal to negative 7. And there we have it. There's our plane. Hope you guys enjoyed the lesson. This is part 3, my 5th time doing this one. Hopefully this one will load up. Have a good day.